But the goal of this problem, so this is that 2.3 problem, is to take parts 5 and 6 and be able to draw a graph and understand how the unit rate fits in, how the points fit in, how all the numbers fit together. First thing is, if I had a blank page, just a blank page, and like you do, and I had the table that you have, of course you could do a graph for this, like a science class. You would take your straight edge and you would, mark off increments. It's really important that you think about how to spread your numbers out. Okay, so in a science class, you look at your data here, and we made some equations for this data. We found out that the number of oranges was n, and it's equal to 5 times the cost. We're going to graph that. Okay, so when you look at that, here's your n, and here's your cost, your c. So you would want to label your axes. So usually we try to talk about dependent variables. In this problem, they do 2 ways. They do this graph, and they also do the graph. You could also graph the cost is equal to the number of oranges divided by 5, like we talked about in the problem above. But right now, we're going to focus on just the first one. So in this problem, in order to figure, this would be more like a situation where I said, you have $20, go figure out how many oranges you can buy. In that case, your money's what we would call the independent variable, because that's kind of what happened first. So if you have $20 and I say, AJ, go figure out how many oranges you could buy with $20, that would be, that would then say that the cost comes first, so that's your independent variable. And this would be the number of oranges. Sometimes it's the reverse situation, where I would say, I need you to go buy 20 oranges, figure out how much it costs. And then that equation would be the one I erased. If we use that equation in red, then we would put the n here and the c there. Okay? But you could get the same information out of both graphs. Okay, but we're going to just work on just this one graph in black, so it's not confusing. Okay? Does that make sense? So then you have to look at your data and say, well, if I'm going to put cost on the bottom, I'm going to mark off, but I know I need to go all the way down to 20 cents to get the unit rate there. But it's kind of hard to look at cents, all those decimals. So, it might make sense to just go, well, I really want to count by 20 cents, but I'm not going to write 20 cents over and over and over and over. So maybe I do something like this, and I make dollars like that. And then I write cost in dollars, and I put a dollar symbol here. And then I would mark off the same amount of dollars here. And then maybe I could fit a third dollar here. So it should be spaced out nicely. Okay, but I wouldn't write 20 cents, 40 cents, 60 cents, 80 cents, because if I did that, it makes it very hard to read. You guys see that back there? But by marking this first 20 cents, that gives everybody the idea of how we're counting. And then you can put in your increments. You just don't need to label every single thing because it makes it hard to read. Okay? And just because I count by 0.2 on the horizontal doesn't mean I have to count the same on the vertical. You see it all the time in newspapers and science. So when I look at the vertical, I'm talking about the number of oranges. Those numbers all go all the way from 1 to 20. So if I want to make one, I could just make one like that. And then if I start to do that in pencil and I go, wow, I'm only up to 5, I'm not going to get enough information there. That's why I use a pencil. Maybe I'm going to go by 2s, okay? And maybe I'm going to shrink them up. Whoops. Shrink them up a bit. And count by 2s. So 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. And then erase and maybe rewrite that up there. And then always show what you're counting by. That's enough labeling. Does that make sense? That's what your paper should look like. Grant. So it depends on what you're drawing, right? So I'm not using this graph. So there's different correct ways to solve the problem. This graph is what you're saying. I could go cost equals 0.2n. But if you look at the question number 6, which is what they originally asked us to do, where's the question 6 right here? Graph the equations from question 5. There's 2 equations from question 5. I'm doing the first one. Okay. So I'm doing n equals 5 times the cost.
So it'd be $1 for every.
Yeah, so here's the data up in this table, right?
Yeah.
So if I wanted to finish the graph, right, I would then, I would put $1 equals 5, so if I went up, I'd be like right about there, right? But I would get that unit rate in. 20 cents gives me an orange right here, right? And I might even ask myself, if C was 0, how many oranges would I have? 0, right? So I'd like that point there. And if I was working with a straight edge and being really neat, I should be able to draw a line right through these. So I shouldn't take the time to plot lots of points. I should take the time to plot 3 points. Because if I did it right, those 3 points would fall on a line. Did I make a mistake?
No, I was just having a question.
Okay. Hold on to the thought. And then I would label the points. So this would be $1 buys me 5 oranges. And this would be the point 20 cents gets me an orange. And then if you went a little bit further to say what exactly does that mean on the graph, if I took my line and I'm just going to make it a little bit thinner here, I should be able to say, well, what happens then if I spend $2? I should be able to go up and then go over and figure out that if I spend $2, I should be able to project up and over. And my graph should show me that when I spend $2, I'm going to buy 10 oranges. Do you get how even though I didn't put all the points on the graph, I should be able to find all the other points by using the graph. Okay, Grant and then Nick.
So if you divide that by 5, it'd be 0.2 oranges, and that for every $1, or would it be, or do you read it like 0.2 per orange?
If I divide what by 5?
If you divide n equals 5c.
Yes. Can we wait for a minute on that graph, and then I can answer that? Because I want to, yes, I want to finish this just so it doesn't get confusing, but that's an important question, and we'll do that. Nick. It's not actually, in this case, the line of best fit because it's exactly correct. So a line of best fit would be when you plot points that have some kind of pattern like this, and then you try to draw a line that shows the trend. But this is not a line of best fit because it actually gives me all the points. I just don't, I just don't want to draw all the points. If I do a nice neat job with my numbering, I can draw 3 points, and then I should be able to look and say, look, all those points work there, like 4. If I go up to 4, so for example, like to go to 4, I would have to extend my graph, right? but 4 would seem to kind of be over here, right? So if I went to 4, it would think, if this were about 4, I should be able to kind of imagine right where that line is going. Do you see that? And even though I'm just sort of estimating, I should be able to kind of go, well, it looks like that should give me about 20. Now, of course, I'm off a little bit because I just did a lot of estimating. I didn't really mark off 4. Does that make sense? So I'm just showing that you guys can plot 3 points, and that actually gives you the whole graph. Okay? So that was part of number 6. The next part of number 6 said, how can you use this graph here to find the unit rate? So you find the ones in the graph. So if I take my line again, and just, I'm going to make it a little thinner here. So if I take my line and I want to show unit rates, well, one unit rate is right here. For $1, I could buy 5 oranges. So you find the ones. So from that unit rate, you have the unit rate that you can get 5 oranges for $1. Okay? Does that make sense? Because it asks, how do you use the graph to find the unit rate? And then you can find the other one. Well, where is the other one in the graph? Where is there another one in the graph? I got the one here, right? I did all that and I didn't get a line. Where's the other one in the graph, you guys? This one right here, right?
Yeah.
Yeah, so for this $1 right here, that's a little, it should be like the dollar right there. I get the unit rate. Do you see that? So this one tells me, right here, this is another unit rate. It says that an orange costs 20 cents. 20 cents for 1 orange. Did I say $1? So there's my 2 unit rates from the graph. Okay? Are we almost, we got 15, okay. So going to those questions on number 6, it says graph the equations. I graphed 1. Just the first one, not the one Grant's asking about. How can you use the graph to find the unit rates? I've done that. Does that make sense? Okay, and then how can you use the graph to find the constant of proportionality? Okay, so that's because you didn't do the reading, right? So on page 47, what does it say about the constant of proportionality, Kat? And I get that you didn't think to do the reading, but we want to start looking. Anytime we don't know what that is, just flip the page back. In the reading, you guys, if you just went back a page, went back 1 page, it's like jumps right out at you, right there. The constant of proportionality right there is the number that comes before the variable. Okay? So it's that unit, and it's that unit rate. Or it has something to do with the unit rate. So if we look at this problem, see, I mean, the constant of proportionality is 5. So in the graph, how can you use the graph to figure out the constant of proportionality? That's what we're going to do. So, let's see if I can. Okay. So basically, if you go up to 5, here, go up 5 units and over, you're going up 5 oranges and over $1. Do you see that? Like, I went from 0 to 5. Maybe if I did it in like a highlighter, you can see it better back there. So if I go up 5, I go over $1. Do you see that? If I go up 5 more, I go over another $1. If I go up 5 more, I would be right about there. Oh no, I went up too much there, sorry. Remember, because 5 is 2.5 units? So if I go up 5 more, that would be to 15, which would be right about here. So the constant of proportionality is always 5, up 5 over $1. 5 oranges. That's why they're not the same. And $1. You see that? So you see it on that stair step. We call it the slope of the line. How much up and over. Yeah, so I could do points forever on that graph by going up 5 over 1, up 5 over 1. Then.
But if it's the slope of the line already has something of a slope, but now it's more or less stairs. And it's going up.
Yeah, but the line is the green part, right?
Yeah.
So the slope, well, the word slope, in this book, they're talking about constant proportionality. It's how much, it's the number formed by how much up and how much over on those stair steps. How much up divided by how much over? What is 5 divided by 1?
5.
It's 5. So that number in the equation, the equation for this graph, they're asking how can you show like a little bit of where that 5 shows up. It shows up every 5 vertical increases you go over an 1. So you could use that over and over and over to plot more and more points. Like I could go up 5 again. This gives me the point 15, 315. But if I go up 5 more and over 1 more, I'm going to get the point. If I go up 5 more units from 15, where am I going to be?
5 more units. Oh, 20.
And if I go over 1 more unit and I extend my line, I'm going to be at the point 420, which is on the table. So I can get to that point using that constant. Does that make sense? Okay. So if we switched it up and used this equation, cost equals N over 5. Grant, this question was, is that the same as this? And it is, because remember when you divide something by 5, it's the same as multiplying by a fifth. So it's also equal to C equals 1/5 of N. And 1/5 is 2/10.
So it's 2/10 of an orange equals 1.
So if I add a page in and just sort of rearrange real quickly and look at both of these together, okay? Instead of that graph there, it would be like it would be, I wonder if I could do this in a way that would help you. If I just took a snapshot of this graph, oops, I get the camera. Is that funny? So if I took a snapshot of the graph, okay, so it would be not only like rotated, it would be like flipped. And so, yeah, of course, it didn't really do that for that flipping. Okay. So basically, instead of having oranges on the vertical, you would have oranges here. You know what I'm saying? And then, so you're going to have that same information in a different organization. Your graph is going to have cost here. So your dollars are going to be $1, $2, $3, so on and so forth. Cost in dollars. So you're going to have your cents, 20, 40, 60, 80, $1. There's your 20 cents. I'm going to do this one not as neat. Oh, because I made a mistake. Thank you. $1. Sorry about that. And then over here you would have oranges, right? So you'd have 1 orange, 2 oranges, 3 oranges, 4 oranges, 5 oranges. Or you might say that's not really enough. I want that to be 10 oranges. This is going to be 2 oranges, right? But you'd have all the same information. So you would still have 20 cents for an orange, but your 20 cents per orange would be here. And you could still get 5 oranges for $1, but your line's going to look a little different because your axes are interchanged. You still would have no oranges cost no dollars, and you take your line and you would just draw your line in still. But you reversed your points because this is 5 oranges for $1. And over here, when you look at that, you have right here, 1 orange costs $5. It gives you the same information. It just gives it different. Does that make sense? And so when you look at the slope, the constant of proportionality, if you look at it on this problem, it's really much harder to see, so I'm going to zoom in a little bit bigger and just focus on the graph we're trying to draw. That constant of proportionality would be every 20 cents you get an orange. You get that? So it's because that number 0.2 is so much smaller than the number 5, your stair steps are smaller, but you still can get all of that from the graph. How?
You said it's cost equals n5, and you said dividing by 5 is 1/5, 1/5 equals 0.2, and 0.7 is the same as cost. That's just a coincidence.
No, that's exactly, it's not a coincidence at all. That's what you're supposed to notice. That 5, since it's 5 oranges, since each orange costs 20 cents, you'd need 5 of those to spend $1. So the unit rates are reciprocals is what you're saying. Do you guys notice that? The unit rate is 20 cents. 1/5 is the unit rate in this view. That's the reciprocal of 5. That's exactly what happens if you change what comes first, oranges per $1 versus dollars per oranges, you're going to have 1/5 versus 5. You're going to have reciprocals. Okay, so guys, this is really important directions. Instead of giving you problem B, because based off of the morning classes questions and the fact that you guys were having trouble on 5 and 6, I did like all of the types of things problem B does. Okay, so if you look at problem B before you leave here.
So are we doing problem B?
No, because if you hopefully were paying attention to that, and if you get stuck and you watch the video, if you look at problem B, here it is, you can answer all these questions. Like, write 2 unit rates. We just talked about unit rates, right? So you would just find the 1, right? So 1 and 30, right? So you'd say 30 miles per 1 gallon. So the new homework is just the ACE problems. Because I talked about all of this in class with your homework just because I thought it'd be easier to focus on your homework. You understand that? Okay, I'm going to post this video as 2.3. Okay, something 2.3.